Okay, today we're looking at solving linear programming problems. So you may be presented with something like this, for example. So we've got a company, Bright Spark Enterprises, produces two computer games. They call them A and B. And in their contracts they have certain numbers that they've got to do. So they've got to do 20 lots of game A and 60 of game B each week. And then, but their production of the factory is restricted by the number of workers they've got, new machinery, etc. So they can only produce 120 a week. And then we've got to look at the profit. So for profit for A games, you get $10 profit, and B games $15 profit. And so then we've got the final thing here: how many of each game should be produced each week to make the greatest weekly profit, assuming all games produced can be solved. Alright, so you're given your restrictions and then you're given what you're trying to find out. So let's have a look at a few things. So we've got to turn these words into some numbers. Alright, so there's two things here. There's production and then there's your profit. So what are your restrictions? Your restrictions is your production. Your profit is then the thing you're trying to maximise, obviously. Okay, so let's have a look at our restrictions. So you've got to have at least 20 A games and at least 20 B games, and you can produce a maximum of 120 per week. Alright, so there's our three restrictions on our thing. So if we're going to do, you can turn them into X and Y if you want to. I don't actually see the point in that, because for me it just makes more sense. Let's make them type A games and these B games. I mean, that makes more sense to me than doing what the textbook does and saying let X equal A games and let Y equal type B games. It's easy just to change your axes. Alright, so what are our restrictions? So the first one is this one here. And so we've got to have at least, so what we know is that A has got to be greater than or equal to 20. So we're going to do at least 20 of those. Next restriction is this one here. At least 60 type B, so we know that B is going to be greater than or equal to 60. Alright, and then the third thing is our maximum of 120 games produced each week. So if A and B are the numbers of each game that are produced, then A plus, oops, let me get back to the black, then A plus B has to be maximum, so it's got to be less than or equal to 120. Alright, so there are our restrictions, our objectives. Now, the next thing, what we're trying to do is we're trying to maximise our profit, so greatest weekly profit. That's what we're trying to do. And what do we know? We know type A games profit is $10. So our objective function is our profit, and let's call it P. And our profit is the number of 10 times the number of A games plus 15 times the number of B games. Alright. So, what do you have to do? Well, first of all of this stuff here, you have to graph it on your graph there. Then, after you've done that, what do you need to do? You need to use the corner point method to find your maximum profit. Alright, so just quickly, to let you know how to do all of that. So there's your 20, we want greater than, so that's out. B 60, it's across there, there's 60, not greater than, so that's all out. And then so A plus B being 120, there it is there. Got to be less than that, so there we are there. Alright, so corner points, work out what those intersections here, there's our feasible region in the middle. Corner points is where our maximum profit's got to be. Substitute them in and away you go. Alright, I'm not going to go into detail of that. That's what all our previous sets have all been about, sketching all that stuff. You should hopefully know that by now. Okay, so read the questions carefully. That's a fairly straightforward one. Read them carefully, get your information out. And once you've set up your functions, your restrictions, functions, and your objective function that you're trying to either maximise or minimise. Alright, so that is set number 5 now, exercise 11E.